Welcome to All Space Considered, everyone. We're coming live, well, sort of from Griffith Observatory. We are still remote, but our signal is coming from Griffith Observatory. And All Space Considered is brought to you by Griffith Observatory, which is owned and operated by the City of Los Angeles. And we'd also like to thank our nonprofit partner, Griffith Observatory Foundation. And now for tonight's show, of course, I have with me Patrick So and Chris Butler, and we also have Bill is going to join us tonight for a special interview that he did as well. So let's take a look at our topics. First of all, smoke gets in your ISS. All Space asks, a star gets triggered with Caltech PhD candidate Dylan Dong. That's the segment that Bill's going to lead. By Jove, and out to lunch. Of course, Chris will bring us all the excitement from space. Pretty pictures and solar system weather with Katie, and eruptions everywhere is our main topic tonight. We're going to be talking about volcanoes in the solar system and here on Earth. Well, you might be thinking, what about Mars? What's been going on? Why are we not talking about Mars? It's been a long time. There's supposed to be a lot happening there. Well, right now, all these wonderful Martian instruments we have are kind of on stealth mode. They have to go explore on their own. They've been given their instructions and they're taking care of business, but they're not able to report back home for a couple of weeks. And that's because we are in conjunction. Well, as viewed from Mars, Earth and the Sun are in conjunction, and as viewed from the Earth, Mars and the Sun are what are called conjunction. You notice signals got to go past the Earth to get to, or past the Sun to get to us. And that's just too hard to do. We can't point our dishes that direction, so we send instructions and wait. But a very quick update as to what's been happening. You can see here the map as to where Perseverance is, Percy and also Ingenuity. Perseverance is right about here, and Ingenuity is nearby. It flew about over to there, and that path is how far they've traveled. Their position, well, the position of Perseverance was captured by the Mars Reconnaissance Orbiter, and this is the HiRISE instrument on board that. We can zoom in a little bit. Turns out Ingenuity was just out of frame on that image, but that is Perseverance right there. You know, look in a great position to study some rocks and look at things. Speaking of rocks, Perseverance did manage to get a sample. In fact, there are 2 holes in that rock now, and you can see the sample inside the drill there. We can compare, there's the drill empty, there's the drill full, and there's Percy looking down at that rock that it's put a couple of holes in. So things are happening on Mars, and we're going to wait a couple of weeks, get some more info, and we'll bring another Mars update to you soon. But for now, let's go a little more nearby, a little closer to Earth, and find out smoke gets in your ISS. What is that all about, Chris?
Well, you probably have heard a lot of people talking about situations of different kinds up on the space station. And the smoke is no joke, actually. There was some smoke during a procedure not too long ago. On September the 8th, some alarms sounded in the Russian portion of the station in the Zvezda service module. They were recharging the space station's batteries there. And they smelled like burning plastic, and there was a bit of smoke in the air. It went away, and they think everything is okay. It didn't turn into a proper fire or anything like that, but it's concerning. Obviously, we're going to want to keep an eye on that, make sure it doesn't happen again. But then also, the other thing that we want to talk about is not just the smoke, but also, I'm going to say cracking up. Because you've probably heard reports about this too. People are talking about the fact that in the Russian Zarya module, which was the very first module, it went up there 23 years ago. They've found some very small cracks, metal fatigue cracks in some structures, about half a dozen of them. They are not large, and there's no air leak. There's no immediate failure that anyone can see. So things are safe, but it's a sign of the station being older. Right? You have to remember, this is something that's going to happen when you've been up there 23 years. We're going to have to watch to see how systems are behaving. I'm not very worried about the cracks. The cracks don't concern me as an aerospace person. But when you mention fire in space, like that smoke with the battery recharge, yeah, that brings back some memories. There was a fire on the Mir space station back in 1997. This is an American astronaut who was visiting aboard Mir, and they did have to don gas masks. They had to fight a fire. They put it out, and everybody was fine. But still, this is the kind of thing that's going to happen as the station gets older. And there are lots of other things too that are just signs of wear and tear that you'll get being on a space station for a long time. For example, here looking on the upper left of your screen, somebody's pointing to something. They're not pointing outside the window. They're pointing to a little ding in the window, which is a micrometeorite hit. They found other things that are the kinds of things that will happen. Upper right, you'll see two pictures. Those are of a drill hole, an error apparently in manufacturing. That's not in the ISS, but on a visiting Soyuz spacecraft. Looks like somebody just made a mistake with the drill, and there was a small air leak, but notice they were able to repair it using fiberglass epoxy resin, and they were able to safely get the spacecraft back to Earth with no problem. That's an example of an in-space repair. Okay, and there'll be plenty of those in years ahead with any space project. At the bottom, you can see the robot arm of the station took a good-sized micrometeorite, put a hole in it. The station's robot arm is working just fine, but again, this is the kind of stuff that's going to be happening. I want to make it clear the crew is in no danger at the moment. Things seem to be okay, but I also want to give you a sense of perspective because I have some aerospace experience. These things are expected when you've been up there a very long time, and we've been getting ready for this for a very long time. The first times we were starting to think about what it would be like to be in space for a long time go all the way back to 1965 and even before that. But with these satellites, the Pegasus satellites, they were actually testing for how often micrometeorites would hit. Would it be safe to go to the moon? Would it be safe someday to build a space station? When we went to the moon and landed next to the Surveyor spacecraft, Surveyor 3, we brought home its camera, not only just for fun, I suppose, but for a real engineering reason. How do things age on the moon? That had been on the moon 3 years. So they really wanted to know about that. You look at Earth orbit. One of the first missions that I worked on when I worked on the shuttle was the LDEF project, the recovery of this big school bus sized satellite whose sides were covered with samples of everything, different kinds of paint, insulation, wiring, computer chips, everything, and to see how it would behave in long duration space flight. This was up there for 5 years, and we did learn a lot about the space environment. This was work we did before we built our space station, and it helped teach us what to do. Now, our station's getting a little old. That's true. Now, we're planning to be there through 2024. Us and the Russians both have committed to that. And there will probably be a bit of an extension, maybe to 2028 or even 2030. But we are going to be replacing the space station. NASA's plans right now are to get a private company to build a space station or a couple private companies. Money is going to be going out to some of them right at the end of this year. They haven't chosen just who, but there'll be a couple of private space stations. The thing to remember is that these space stations will draw on the experience we've had with the ISS of how structures behave if they've been in space for a long time. These are the skills that we're going to need if we're going to go back to the moon, if we're going to do voyages to Mars, live on Mars. We need to know how to fix things in space. Like this space shuttle astronaut practicing how to repair heat shields, we're going to have to be space repair workers in addition to scientists and all the other things we're going to be. It's just a part of living out there among the stars. Back to you, Dave.
Thanks. Interesting stuff there. I've heard engineers, when designing some of space equipment today, they're using fairly old technology because they know it worked. If there's a satellite that's still working today and what's on board was working and still works 10, 20 years, well, that's good stuff. The stuff that failed you don't use. So some are complaining technology isn't advancing fast enough in some ways, but you want to go with what works. But interesting stuff, and times are changing, we can say. So right now, Bill, are you out there to join us? Are you in the room here? There you are. Welcome.
I am. Hi, thanks.
Yeah, everybody, I'm going to explain a little bit about what we're doing here. We've decided to create a new segment called All Space Asks, and we'll do this periodically, well, not even periodically, sporadically, I should say, where when we find an interesting story and someone we want to talk to, we're going to send one of our All Space Considered correspondents and producers to talk to this person. And this time we sent Bill virtually via Zoom to talk to PhD candidate Dylan Dong. He's over at Caltech, and he had a very interesting story that we all decided would be a great one for this first time we do All Space Asks. So, Bill, do you have any comments about the interview before we just go ahead and run it?
It was a blast. That's one thing. I mean, I think we have about 7 minutes here, but we are posting the entire thing, which was about 25 minutes worth, and I could have gone another 25 with him. He's so full of interesting information. I want to say that what he discovered, he and his team discovered, he is the lead author on the paper, that what he discovered had not been discovered prior to this. And it feels to me like a very fundamental astrophysical phenomenon. So I won't say any more than that.
Yeah, anyway, enjoy everybody. And like I said, he does get a little deep into the astrophysics here a couple of times, but we added some graphics to help you along. And as always, you can type in questions into the YouTube chat and we can answer those afterwards, perhaps. So enjoy this, and thank you, Bill, for taking the leap and being the first one with our new segment.
Hi, everybody. This is Bill Grinenberg. I'm reporting for All Space Considered, and we're talking today with Dylan Dong. Did I pronounce your name correctly?
Yep, that's right.
Okay, and you are a Caltech postgraduate working on your PhD, is that right?
Yeah.
And you made a discovery that I found just fascinating, and as I was saying in our little pre-talk, just really fundamental. It feels like fundamental astrophysics. So the first thing I'd like you to do, if you can, is describe briefly, and language people who aren't astrophysicists will get, what you actually discovered.
So our story begins with two massive stars that were born in a very close binary. And one of them blew up in a supernova and left behind a black hole or a neutron star. That's the remnant whenever you have some sort of core collapse supernova. And the other one is still living its life as a massive star. So this black hole or neutron star is pretty close by to this other star, and it starts eventually siphoning off mass from the atmosphere of the other star. You get basically a stream of mass getting pulled off of the star onto the black hole or neutron star. And eventually, this causes the black hole or the neutron star to spiral in and plunge into the atmosphere of the other star. And within that star, it starts to sink. It's still orbiting the center of that star, but it's also sinking as it's orbiting. And as it's sinking, it's basically splashing out the entire atmosphere. Think of like a garden hose spraying it out into space, right? And this whole process, we think, probably takes a few centuries. And by the time it reaches the core, this material has been splashed out to like 10,000 times the size of the original star. And meanwhile, when the black hole or the neutron star reaches the core, it starts all of a sudden siphoning in huge amounts of mass at once. And what forms is called an accretion disk in the center of the star. And in this accretion disk, there are all sorts of magnetic fields that are tangled up. And this process releases a huge amount of energy. It launches a jet at close to the speed of light. And that jet basically bores its way out of the star and releases X-rays as it breaks out of the star. And that's what we saw in 2014 with the MAXI instrument on the International Space Station. Mm-hmm. Meanwhile, all the energy that was released at the core of the star explodes the star. And the guts of the star doesn't get vaporized. The guts of the star actually fly outwards, right? And as those guts fly outwards, they eventually catch up to all the things that, like the garden hose that was released centuries before. The guts of the star basically crashes into all that slower moving material. And that crash is what we call shock. And that shock is what produces the luminous radio emission that we saw later with the Very Large Array. I like to think of it as when you have a regular supernova, you're basically creating one of these objects, right, at the core. But here, you're sort of bringing it in from the outside. Imagine like a speck of dust, basically, orbiting this absolutely massive star. Yeah. And that speck of dust makes its way inside of the star and cannibalizes it from the inside out.
So were you guys looking for this? I mean, because I know this had been theorized as a possibility, or was it you found some interesting kind of anomalous stuff and then came up with this explanation, this model?
Oh, definitely the second one. I had no
okay.
idea this model even existed before.
Really?
Yeah.
Who did the theorizing on this? I mean, who first suggested this could happen?
This particular scenario, the specific one, was first suggested by Roger Chevalier in 2012.
Okay.
And what he was trying to do was he was trying to explain why you have certain supernovae with huge amounts of mass that are sitting right outside of where the explosion site was.
Now, how confident are you that your model is the correct description of what happened?
We looked at pretty much every model that was out there, and we tried to make them work.
Okay.
And
this one fit.
And this is the only one that worked.
You know, the radio wave, the transient radio emissions that came from the matter running into the other matter, was that a specific wavelength? Is that how you is that like a fingerprint of this exact kind of thing happening, or was it just massive, radio emissions that were transient? I mean,
things that were there really, really strong shocks that are of the order the size of a tenth of a light year will be extremely luminous, will peak at around to the frequency that we're observing. And so we'll see more of those events.
Can you like write an algorithm that'll just sort of scan data and find this kind of thing happening again, or?
Yeah, so you asked me about my thesis. What my thesis really is I've basically data mined the entire VLA sky survey. I've made a catalog of all the millions of radio sources that are in the sky, and I'm looking for how the radio sky changes over the course of years to decades.
So do you think this is a common occurrence?
It's actually really unclear how often this kind of thing happens. So there have been theoretical predictions for how often neutron stars enter their companions and settle to the core. And if I'm remembering correctly, I think this is supposed to happen once every 5,000 years or so in a galaxy the size of the Milky Way.
Which means a lot, just because there's so many galaxies.
Based on just this one detection that we have within our search, I'm able to say it probably happens more often than once every 10 million years in a galaxy the size of the Milky Way or so. But it's possible that there are other manifestations of this kind of phenomenon that we just haven't observed, and so it could be a lot more common.
Why do you think this hasn't been discovered prior to now?
Yeah, because we haven't had the VLA sky survey before. We simply have not had the sort of wide field, sensitive, high resolution survey over multiple epochs. And it's possible actually that supernovae that we've already observed are actually due to this sort of mechanism, and we just haven't realized it yet. Right.
Okay. Well, Dylan, thank you so much. I really appreciate your taking the time to talk about this really incredible discovery. This is just a very interesting new piece of the puzzle of the universe, I think. So thank you, Dylan. You're going to go on to do great things.
Thanks, Bill. Appreciate it.
All right.
All right. So thank you, Bill, for that interesting interview with that PhD candidate, Dylan Dong. I want to call him Dr. Dong already. But so what's going on here, folks, as far as I can tell, is that you had two stars born together. The more massive one's going to die first. And when it died, it went supernova and made a black hole or a neutron star. We could have been either. And then the two spiraled together and it set off the companion star before it was really supposed to even go supernova. So this is a new mechanism for triggering these stars to explode. Now, am I correct, Bill, that this is the first one they've seen, that this was theorized or hypothesized is the correct word, and this is the first time that it's been observed?
Yes, absolutely. Everything I've read about it says that we haven't actually seen this exact thing in the data before. So yeah.
Anyway, great choice for a first story to go get more information on. Again, that's a detailed explanation of what was going on there, but great stuff from a local PhD candidate here in Southern California at Caltech. And thank you, Bill, for providing that for us.
Sure. And
now we're going to...
If I may, just I want to say again, I think tomorrow we're putting the whole interview up. If you like extended interviews, it's really a good one. He had a lot more interesting stuff to say. Yeah,
be sure to subscribe to our channel, and if you want to get notifications, as they say, ring that bell, and you can get notifications as we post these videos. And we're posting more and more, and we're going to start doing more things like this, and you'll get content you haven't seen before. So do subscribe. Now we're going to turn to our inquiries from our foundation. And this is the time that we'd like to thank our foundation, Griffith Observatory Foundation, for so much what they do. They provide a lot of the equipment we use. As you notice, you can actually donate to the foundation right now, their campaign, and those funds go to support our school program, which is running online right now. We've served over 6,000 kids just in the last 2 weeks and a day. So we're really serving a lot of children in the area, and we also like to give back a little bit. And we asked the foundation to provide us with questions. And this month, we got a question from William that said, what are the leading ideas for protecting astronauts from radiation on long-term missions, such as ones to Mars? Well, as you can see here, we have Starship, which is an enormous rocket. The top part's the Starship, the lower part's the boost phase. Chris is going to tell you a little bit more about this. It is big enough you can carry shielding with you. And the best idea for shielding is something you're going to need and use when you get to Mars. So things like water. Put your water tanks in between the astronauts in the direction you're going to get most of the radiation, which would be the sun. The sun's going to be giving off a lot of particles. You don't want to have those hit you. So that's the sort of protection they're going to have to think about. The fuel tanks are pretty good. Any sort of mass that you have between you and the source is pretty good. Now, if something goes off in deep space, gamma rays come flooding through, it could be a bad day for them, but that's a risk that astronauts have to take. Right now, we couldn't launch enough lead to make it an absolute, you are covered no matter what. So great question, though, from William. And if you want to have your question answered next month, join our foundation, and you too can send in a question. Right now, we're going to turn to Jupiter by Jove. Now, Patrick, what's been going on out at Jupiter?
All right. Juno on September 2nd made its 36th close pass of the largest planet in our solar system, and its closest point to the planet is known as Perijove, or PJ36, which is indicated by that blue arrow there. That's when the spacecraft flies at maximum velocity of 130,000 miles per hour and is roughly about 3,000 miles above the cloud tops of Jupiter. During this time, JunoCam, its onboard camera, is taking pictures, and there's various instruments analyzing the structure of Jupiter as it flies by. It does have a unique orbit where it takes it over the polar regions of Jupiter, giving us images never be seen before from Earth because of its orientation of the poles with respect to the Earth. So we're going to take a look at some of these images that it just sent back, beginning with the polar region look, which is, as you can see here, is in this colored enhanced image provided by the public. They basically take the raw images and enhance them so we can see some of the detail. The northern region is kind of bluish in enhanced color, and there are lots of cyclones there. They're called circumpolar cyclones that literally circle around the polar regions of Jupiter. I put in the circle here some photofilamentary regions, and as you can see in the next image, as Juno glides down from the pole towards the equator, you can see those clouds move up there. So these pictures are taken tens of minutes apart, and as Juno is approaching its perigeo point. Now, near the bottom of the picture, to the right and the left, you can see there's a change in coloration, and this is where Juno is approaching the north temperate regions, where you see a lot of turbulence, and its field of view is getting a little bit smaller. So we're seeing a smaller view and a closer view of Jupiter, with the images getting more and more high res. There's a storm here with really high detail, including those white clouds, which are the ammonia ice crystal clouds, almost like pop-up thunderstorm clouds above this storm. Nearer to the equator, the coloration turns kind of reddish in this north temperate belt. And you can see in exquisite detail some of the intricate, swirly, turbulent patterns in this just incredible view of Jupiter up close. This is an interesting storm, kind of a kind of brownish spot with some smaller brownish spots creating turbulence in the southern hemisphere of Jupiter. And as we back out, you can see the spot is very distinctive. It's just below that kind of brown kind of belt, which is known as the South Tropical Belt, and that's the view that we can see. We can see a little bit more of it because Juno is receding from Jupiter. Now, these are just a smattering of the images that were returned by Juno, and to see more, you can go to this website to see some of the incredible images returned by this Juno spacecraft, which has been orbiting around Jupiter since 2016. All right, and back to you, Dave.
Well, I think one more thing happened to Jupiter, if I remember right, Patrick.
Oh, yes, of course.
Something that was a little bit...
That was a little bit short because now for the encore.
Encore.
Okay. Okay,
Oh,
let's
it's a
do the encore.
surprise that it happened.
Well,
All
it
right,
was.
so all right. So Juno's been observing Jupiter up close, but here on Earth, many amateur astronomers have been taking in the view of Jupiter. And during, in fact, on September 13th, a flash on Jupiter was recorded by 7 amateur astronomers around the world at a specific time. And this flash is within this red circle, and you can see it there. Also, the same flash was recorded in Brazil, and you can see it right there. It lasts about 2 seconds, and it's thought to be an impact of an asteroid or a small comet hitting Jupiter. So that's an incredible recording and very rare to see an impact happening on Jupiter. Now, Jupiter is not a stranger to impacts. The most well-documented case of an impact on Jupiter was back in 1994, when Comet Shoemaker-Levy 9 smashed right into Jupiter. These images are just a sequence taken by the Galileo spacecraft at the predicted time of the impact. And it left these large scars across the southern hemisphere of Jupiter. So this was actually seen by myself and several observatory employees at the time. We actually were open at that time, and we had a crowd of people anticipating the impact. And lo and behold, we saw these scars move as Jupiter rotated them into our field of view through the telescopes. So an incredible time to actually witness an event in real time. And actually, Jupiter is not the only object that could get impacted. All solar system objects impacted one time or another. And we caught our own impact, actually not our own here, but during a lunar eclipse in 2019, while we were broadcasting live to the world, the lunar eclipse from Los Angeles, we saw a bright flash, which is indicated there by the arrow there, which only lasted less than 1/30th of a second on our 30 frames per second video. So that's something rare and incredible. It's almost like watching lightning. You only see it once. You got to be there at the right time, at the right place. All right, and now actually back to you, Dave.
Yeah, well, I remember that impact flash on the moon. That was really something. And also Shoemaker-Levy 9, I was in graduate school, and I remember some of the professors there running down the hall talking about the images from Keck that were coming back with the infrared instrument there. And it was one of the first instruments to pick up a glow after the impacts on the far side. It didn't impact on the near side, but amazing stuff, the impacts. So speaking of impactful events, we're going to talk about what's launching. There's always something else going on. So Chris, what's launching and what's been launching?
Oh gosh, it's been busy. Actually, it's been busy ever since I've been doing All Space Considered, which is great. There's a lot to talk about. As far as what's going on right now, well, let's take a quick look. First of all, we want to follow up on something we talked about last month, which was very exciting. The first trip of amateur, just space travelers, not professional astronauts, into orbit. This wasn't one of those small little hops that they were doing with Blue Origin and Virgin Galactic. SpaceX actually sent these people to spend 3 days in orbit. Now, everything went well. They're back on the ground again. Fantastic. The only difficulty seems to have been with the toilet, a little bit of a problem. I don't have details on it. And ladies and gentlemen, I don't want details on it. That'd be TMI. Apparently, it's not a serious problem, but they're looking to improve the spacecraft next time with an oven and better Wi-Fi. Well, that's the business of running an airline in space, I guess. That's great. We have something else unusual going on, launching October 5th. This is a Russian launch, and the woman on the left of your screen is an actor. She is going to be filming scenes in space for a film, a Russian film called The Challenge. And the man on the right of your screen is the director who will be holding the camera and giving directions and all the rest of this. The man in the center is a professional cosmonaut who will be flying the vehicle and taking them up there. Now they're going to spend, the actor and director, 12 days in space shooting this, and then they'll come home, not with the same cosmonaut. There's someone else coming back down. They'll ride back down with them. A fun thing about this, this is a little bit of a Hollywood space race going on here, because you might have heard our own Tom Cruise has ambitions to go up into space and to shoot scenes for a movie with him starring and bringing up a director. He's apparently going to do that very soon on a SpaceX vehicle. So more power to them, and break a leg, I guess we can effectively say, for flying in space to do that. Here's something I'm really looking forward to. We got a great launch coming up. This is October 16th. This is the Lucy mission. The Lucy mission is an asteroid exploration mission going to launch from Cape Canaveral on the 16th of this month. This is just the beginning, of course, of a 12-year mission to explore 8 asteroids. Now, you may know most of the asteroids lie between Mars and Jupiter. They call them the main belt of asteroids. And we've visited a few before, of course, but this is actually going out to some places we've never been, the so-called Trojan asteroids. They're farther from the sun. They are indicated by the ellipses there, the yellow ellipses. This is a swarm of asteroids that leads Jupiter in its orbit, goes around same speed, doesn't run into Jupiter, and a group that follows Jupiter in its orbit. And they're named for heroes of the Trojan Wars, hence Trojan asteroids. Anyway, they're really exotic, and they're bound to be interesting. We've never seen anything quite like that. And this journey to visit 8 different asteroids is going to start on October 16th. We should mention the Chinese are at least supposed to send up a crew to their brand new space station, right? Talking new space stations there. They were scheduled to on October 16, but we don't have a lot of confirmation from them yet. A crew has not yet been announced, but keep your eye on the different websites and so on to see maybe the Chinese are going to send a crew up. Now, Dr. Reitzel mentioned that Starship remains in testing down in Boca Chica, Texas. Indeed, they do. The 2 parts of the rocket are not stacked right now, one on top of each other. They're located next to each other, out next to the launch tower. They've been doing a lot of work on the launch tower, which has giant service arms and so on. In fact, arms that may catch the rocket boosters from the air, catch them. It's pretty crazy stuff. They're working on that, and they're also starting to do some of the testing on the vehicles themselves, practicing with the engines, practicing pressurizing their fuel tanks, and so on. That's all going on while the FAA is working on legal questions. They want to make sure that all the permits are dotted I's and crossed T so that they can launch this massive rocket. We don't know just when it'll happen, but things are progressing. Anyway, Dr. Reitzel, I guess I will toss it back to you.
Well, thank you for that. And just crazy stuff with SpaceX. They just keep doing more. Well, now we're going to turn to the Sky Report, and Patrick's going to tell us what to look at up in the sky when we're not watching rocket launches, that is.
Let's go to this beautiful image that was taken last month, showing the crescent moon and Venus, which is that little dot in between the clouds there. Venus is actually visible right now from Los Angeles. If you take a peek out to the southwest, towards the southwest, you'll be able to see what looks like a very bright star-like object. That, of course, is Venus, and has been in our skies and dominated skies for a few months now, but it is getting lower and lower. And so we'll soon lose our view of Venus sometime next month. But in the meantime, we can still enjoy a view of Venus next to the moon. If you missed this one last month, there is another opportunity to see Venus and the moon again on October 9th. So looking towards the southwest, the moon and Venus are roughly about 3 degrees apart, and the moon is just about 4 days old. So there's a beautiful opportunity to look at it, and even take a picture with your cell phone and capture that moment. So what else is happening in the sky? Well, the moon, we all know, moves around the Earth, and as it does so, it appears to move around the sky. And the next event is the moon will be just below the planet Saturn on the 13th, and the moon is separated roughly about 3 degrees apart. It's kind of similar to the moon and Venus, and it's roughly about 8.5 days old. It's a waxing gibbous moon. So you ought to take a look at that. That's towards the south in the evening. The next day, the moon approaches Jupiter, separated by the same distance. And Jupiter is, as we talked about, easy to see. It's very bright compared to Saturn, which is much further away. Now, the stars behind Jupiter and Saturn are very faint. It's actually the stars of the constellation Capricornus, made out of a lot of faint stars and hard to see from our light polluted cities. But you can actually see them if you're far away from the city lights. And this image was taken by our telescope demonstrator, Anthony Perkett, showing Jupiter and Saturn in the picture on the left. And you can see the stars of Capricornus. If you can kind of follow them, they look like, if you can almost make a triangle kind of with bended edges there. On the right, we join the stars together to form the constellation of the sea goat, which is what Capricornus is. So it's, if you're out camping or out in a region where it's dark, you can certainly take a look and see if you can find the shape of Capricornus.
Yeah, I'll say, Patrick, it looks like every sea goat I've ever seen.
Yes.
Yeah, it's a dead ringer. It's incredible.
Yeah, we already put some artwork to that and have the mythological version of the sea goat. Now, because Jupiter and Saturn are visible, it is really a treat to look at, especially through telescopes. Here's our very own Zeiss 12-inch telescope on the night when we're open. We're open Fridays through Sunday, and if you have a chance to visit the observatory and have a chance to look through that telescope, we are viewing Saturn and Jupiter throughout the evenings there. What would it look like through this telescope? Well, we have a couple of pictures taken by our telescope demonstrator. This is an image of Jupiter with lots of detail. There's a northern temperate belt, and there's two elongated dark features there, which are actually barges. And then below is the great red spot. The other picture is, of course, the Saturn, and you can see its rings even through a telescope, even through a small telescope, and its Cassini division, which is that divide in the rings that is visible there. Now, turning from our evening sky to our morning sky, there are no planets visible, but there are lots of interesting constellations to look for. And you might want to get a head start if you're up early in the morning looking to the southeast, looking in a region of sky containing many bright stars and many famous constellations of the winter sky, starting with Orion the Hunter. The other constellation is right below it, is Canis Major, the great dog, with the brightest star in the night sky called Ceres. Ceres at this time is kind of low above the south east horizon, and usually there's a lot of atmospheric turbulence that causes it to flash in all colors of the rainbow, and people have been fascinated and even called the observatory about a star with multicolors just rising above the southeast. Gemini, the twins, don't forget to catch that. So if you have a mobile phone with a star astronomy a planetarium type of star identifier, you can look for the stars of Castor and Pollux. And of course, Horus the Bull, its bright red star, Aldebaran. Now, talking about Orion, on the night of the 20th to the morning of the 21st, there is the Orionid meteor shower, and its radiant is just above Orion, hence it got the name the Orionids. And this shower is not a big shower, but just from a dark sky area, it produces about 19 meteors per hour under ideal conditions. But you can see on the right there, the moon is in the way. The moon is near full, so it will impact your viewing of the Orionids. But nevertheless, the Orionids do produce a few bright meteors from the shower. So you might catch a few if you're up at early in the morning on the 21st. And speaking of the moon, here is our moon calendar for this month. And we have new moon on the 6th. First quarter is on the 12th. Full moon is on the 20th, and last quarter is on the 28th. And that's your sky report for this month. So go out and observe the skies.
Well, thank you for that, Patrick. And everybody, keep in mind, if you're someone that likes to go out and observe, if you have a telescope and a camera, or even just a cell phone, like Patrick said, go out, document that moment. You can keep it for yourself, but you can also share it with us. You can tweet at us, you can email us, reach out to us. We have our social media information at the beginning of the show. We'll have it again for you at the end. And we'll show your pictures too. If you take something that's fun and interesting, we'll add it. And this is the section that we like to do that in. In fact, it is time for Pretty Pictures with Katie and also solar system weather. So Katie, what do you have for us tonight?
Our first couple images are telescopic images from telescope demonstrator Anthony Perkic. This one here is the Cocoon Nebula in constellation Cygnus. Beautiful image. And then we have the Helix Nebula. This one's in Aquarius. And these two are from David Pinsky. This is the September 13 SpaceX launch of Starlink. This is a sunset that I took during a hike in Griffith Park. And a beautiful harvest moon over New York City. This one's by Alexander Krevenishev. And another one of the moon there. Then we have the first sunset of autumn. On the left is from David Pinsky, and on the right is Anthony Perkic. And that same evening, this is Jupiter and Saturn above the Samuel Ocean Planetarium Dome at Griffith Observatory from Anthony Perkic. And this is another Pinsky image of beautiful Jupiter and its moons from left to right. We have Io, Europa, and Ganymede far off to the right there. And then this one is from Damian Peach. This is Saturn from 2004 on the left, all the way to 2015 on the right. And then some beautiful cloud images. These are from Eric Whitaker, who was our guest on All Space Considered in previous months. These are some altocumulus clouds over Los Angeles. And then these are some stratocumulus during a sunset in winter 2020 from Eric Whitaker. And here we have our sun from September 11. The sun was very active in mid-September and actually produced some incredible aurora. This video is from Evan Zucker, and him and his wife actually took a trip from San Diego all the way up to Alberta, Canada to get these shots. And that's from Paula, just beautiful images. That leads us to our NOAA Aurora probability forecast for today. Left is the northern hemisphere, and on the right is the southern hemisphere. So it doesn't show too much. You can see the probability on the bottom left there. bright green is about 10% or so. But keep checking this if you are interested in viewing some aurora.
Thank you, Katie. In fact, if you're interested in aurorae, we're headed towards solar maximum. Of course, it is the sun's solar wind coming off of it, interacting with the Earth's magnetic field that generate the aurora. So the sun needs to be active to have a strong magnetic field, and we've been at solar minimum, but we're coming out of it. We show images of the sun to our school kids that come to our school program, and lately there's been some sunspots, and sunspots indicate activity, and activity means more auroras coming. So, you know, plan those trips to the northern regions or the southern regions, and you might get to see one yourself.
Yeah, I'm really excited. Next year, I'm going up to Norway. So it's sounding good.
Wow, well, those are my people up there. I'm part Norwegian and German, and yeah, so.
Me too, yes.
So, well, that explains the Viking ship. Anyway, folks, it's now time to turn to our main topic of the night. We are going to talk about eruptions everywhere, and we were looking and thought, gosh, there's eruptions going on, and the image on this picture is of La Palma, which is a part of the Canary Islands owned by Spain. And this my friend Michael Reich took. He's a friend of mine. He's part of my Burning Man camp, actually. A really good astronomer, works for Botter Planetarium, and really knows his stuff. He took this one with a telescope about 1 kilometer away from the eruption itself. Here's another shot of it off in the distance, just a beautiful picture. I'm sorry, I just stole this one and didn't credit it. It was last minute ads, but that's the way it goes. Sometimes the art has to come first, and we're nonprofit and educational. We're teaching you here. For example, Earth has over 1,500 potentially active volcanoes. So there are a lot of volcanoes that could be going off. I mean, there's literally dozens and dozens that are erupting right now, this second, and you can see a pattern to this. If you notice, many of them kind of track along this rim, and that's known as the Ring of Fire. And that's caused because of plate tectonics on Earth. You have regions where a plate is diving under another one, putting energy down there, creating extra heat. That magma has to go somewhere. Well, let's take a look at the different places it can work. So on the left, as you can see here, you have a plate that's going down under, extra energy, and up pops a volcano. Over on this side, you have a rift zone. Literally, the plates are spreading there. Material's coming up and new crust is coming up to the surface. So you have a spread there where you can get volcanoes in that region. Here's another subduction going under a continent that's floating up on top of a plate, where another one goes down under, you can get interaction and up pops a volcano. This is like the Cascade Range, all the ones in California, up near Mammoth, they're caused that way. But out here in the middle, notice, there's one that's not associated with these plates. It's just a hot spot, a plume coming up over and punching its way through that plate. That's like Hawaii. I have to say, that's the Hawaiian Islands, the Aleutian Islands, and others are formed that way. So you can get volcanoes made different ways. Now on the right-hand side, you can see you have a magma chamber, and this changes all the time. This is oversimplified, so geologists out there don't freak out. This is just a basic picture. But magma out there rising up, and it'll take an easy way out. And you can get all sorts of different sorts of activity from a volcano. Of course, you have the big plume of smoke and ash that comes down, ashfall. You can have lava flows. Everybody's familiar with those. That's the classic. You can have what are known as lahar. They're mud flows. You can essentially melt snow and ice that's at the top of these volcanoes, and huge amounts of mud can flow down. One of the most dangerous are known as pyroclastic flows. Those are essentially heated, superheated material coming down like an avalanche, setting everything on fire in its path. So you can throw out giant bombs, as they're called. They're huge boulders that fly up out of it and land. So volcanoes, you need to be an expert to really study them. I don't recommend going close to them unless you know what you're doing. Scientists, we have all sorts of instruments that we put near these volcanoes and next to them. Indicators to mark position, to track how the ground is moving, deformation indicators that are seeing how it's tilting, and just in general, things measuring seismic indicators as well. You want to be measuring the earthquakes underneath. As you start to pick up more earthquakes, it says there's an eruption coming. Now, do you need to worry about one nearby? Well, sure. If you happen to be right here in Mammoth, California, maybe you like to ski, maybe you're a snowboarder, great place to be, but also it is a dormant volcano that has rumblings underneath. There are earthquakes under there. Now, they're not building to the point where it's going to erupt any moment, but notice it's red. That means this is one that has a high probability, or even very high. Right up the Cascades, there's a mixture of high and low probabilities. Down here in Southern California, there's a couple of pretty much, not much is going to happen, very low, but there are some volcanoes down here. Notice Hawaii currently erupting, that's Kilauea. You have the Aleutian Islands as well, with several erupting volcanoes, as well as the Marianas. So there are active volcanoes here in the United States. What about elsewhere in the solar system, though? Elsewhere in the solar system, there are volcanoes to talk about. So let's talk about those, and we'll come back to Earth after we talk about the solar system. This is a dwarf planet known as Ceres, and Ceres is in the asteroid belt. So it is a large object. It's worked itself into a sphere, but it has an ice volcano known as Olympus Mons. We think this material is pushed up and it cascades down the side. You can see the various views of it, and we honestly believe there are 20 some other potential ice volcanoes that could still be active on Ceres today. So very exciting, very interesting. We see salts down in the crater of this thing that are associated with water that's recently been sublimed off into space. So Ceres, super interesting object. There's also Triton, which is a moon of Neptune, which we haven't visited Neptune in a very long time. Voyager flew by it. There's been some flybys, but as you can see in this image, there's some strange little black wispy things that all seem to be kind of traveling in a similar direction. Like there's a wind of some sort blowing this material. How is that happening? Well, let's move forward and take a close-up look at the terrain. Looks pretty smooth. It looks like there are flows there. In fact, you can see some places where it might be coming from. Potentially more ice volcanoes is what we're thinking. And in fact, when Voyager flew by, Voyager 2 took these images, now not super high resolution, as you can see, I've zoomed way in, but watch, over a 15-minute period, this is what happened. Not much there, maybe a little something, and then the last image, suddenly a plume shows up. So over a 15-minute period, we captured one of these eruptions happening on Triton. So Triton has volcanism of some sort. It's probably an icy material like water coming up from underneath. So not much there, a little bit more, and then finally, boom, there it is. Now, these aren't perfectly aligned. My apologies for that, but you get the idea. As you can see here, finally, one last image of Triton. It shows you those black lines coming off. It's sort of the black material, most likely eruptions. Now, the most volcanically active object in our solar system is actually Io. It is a moon of Jupiter, one of the big ones, one of the Galilean moons. And no, those aren't pizza toppings, although that isn't black olives and pepperoni. This is actually sulfur-rich material. It's come from the inside of it. Io has a lot of sulfur. It's very close to Jupiter, so it's being tightly stretched and moved, which keeps the insides molten. And it makes it the most volcanically active object. There are volcanoes going off all the time on Io, and you can see in this GIF, Tvashtar, I think, is the one up in the upper part there. Loki's the largest volcano on Io, and here's another shot taken by New Horizons. It's got to be Tvashtar up on the top, but another one off to the side here erupting. Yeah. So very, very volcanically active and super interesting. Well, what about other planets? How about Venus? Earth is volcanically active, as we know. Venus is nearly the same size, doesn't have a moon to be doing tidal forces. But Patrick, do you think that Venus has? What's the latest there?
All right, well, let's take a look at Venus. As you can see here, this is an image taken back in 1974 by the Mariner 10 spacecraft. Venus is completely covered in clouds, and it's the reason why Venus is the second brightest object in our night sky, mainly because the clouds reflect almost 90% of the sunlight, but those clouds are really thick. They're roughly about 15, there's a 15-mile cloud layer, making it difficult for us to see any type of geological or even volcanic activity on Venus's surface. Now, if we were to be on the surface, as in this graphic here, it is not a very pleasant place to be actually standing on. And we kind of referenced, David referenced pizza there. The temperature is almost like a pizza oven down on the surface. And not to mention, which is not mentioned in this graphic here, that the atmospheric pressure is 90 times that of Earth. It's like being underwater at a depth of 2,625 feet. So really crushing atmosphere. And the atmosphere itself is not breathable. It was pure carbon dioxide, and the clouds above are made of sulfur dioxide and sulfuric acid. So anyway, with all of that, how can we even determine what's going on geologically on the surface of Venus? Well, back in the 1990s, and we're going to turn to this, this spacecraft was launched by the space shuttle. It's called the Galileo. And Chris, you had some connection with this mission.
Yeah, this was one of the very first missions that I supported when I worked for Rockwell. And it was the first time that a space probe was launched from the space shuttle. So the Magellan mission to Venus was a big deal for us when Atlantis got it launched safely.
Well, Chris, I thank you for those efforts, because this spacecraft traveled a few million miles away from Earth and from the space shuttle. And you can see that there's a big dish there, almost like a radio dish. And that, in fact, that's a radar dish that would be able to send radar and bounce it off the surface of Venus. And basically it will penetrate the clouds. And what Magellan did was, in its 4-year mission around Venus, was able to map 98% of the Venusian surface down to a resolution of 390 to about 985 feet. That was incredible. It gave us an incredible view of the surface, and you can see it's very varied. And it also sent us back altimeter data, so we could actually use that data to create these incredible 3D views of what various features would look like on the surface. We're looking at Mount Mons, one of the largest volcanoes on Venus. And yes, it's a volcano. In fact, scientists took all of the Magellan data and tried to identify all the volcanic features of Venus. And they made this map, which shows that Venus is basically plastered with volcanoes. There are more volcanoes on Venus than any other planet in the solar system. And there are various types, some of the large shield volcanoes down to small volcanoes, and even volcanoes that look like pancakes or corona type volcanoes. So do we have any evidence that that these volcanoes are active today? Is there any recent activity happening? In fact, right now as we speak, and if you were looking at Venus today and in the evening sky, is there a volcano or several volcanoes erupting? Well, we only have clues, and these clues came from a spacecraft called Venus Express. It was in orbit around Venus from 2006 to 2014, and it carries an instrument that can detect infrared. And this image was made from data from Venus Express, showing infrared, a signature of infrared heat from a volcano called Olympus Mons. And that is giving us a clue that there actually is some volcanic activity, whether it's actually erupting or not, but you have some telltale signs here. And apart from that, there have been some recent papers suggesting what we should look for in terms of clues of volcanic activity on Venus. This paper says that there's a role in phosphenes. Phosphenes, we did a story last year. It was a big story that phosphenes were found in the atmosphere in the clouds of Venus, and scientists were excited because it is basically like a biomarker and the signs that there might be microbial life in the clouds of Venus producing phosphine. That debate still rages on among scientists, But there might be another mechanism that the source of this phosphine might be from explosive volcanoes that are happening right now on Venus. So future space missions should be looking for a geological or a volcanic source of phosphines. Another method, because of all those clouds, we can't really do much, is combing through, here's another paper that scientists comb through the Magellan data and look for various structures for deformations left by volcanoes. As a volcano grows, it deforms the ground around it, mainly because of its mass there. And the deformation, the more the deformation, there are signs that you might be able to find out that the crust is thinning, and there might be a detection of giving us an idea that there might be more heat flow, and that area might be young and volcanically active. They did a study on this particular corona type volcano called Arimati corona. And so the degree of definition can offer clues of how young or how old a volcano might be. The problem is that the data that was gathered by Magellan is 30 years old and has basically been combed through, and literally we're running out of data and we need new data. So what's next? Well, just recently, NASA announced 2 missions in its Discovery program. In fact, just a few months ago, missions to Venus. One is a mission called Da Vinci Plus, which will send a space probe through the atmosphere of Venus and land on the surface and sample the composition of Venus's atmosphere. And then there's this mission, which is Veritas, which is a mission to map in very high resolution the surface of Venus using the same kind of radar technique that Magellan used 30 years ago. But we have now, technology has advanced, and we can even map with even more precision than ever before. This mission will be launching in between 2026 and 2028. It's being in development right now. And it could offer us some clues to whether or not Venus is actually volcanically active. And this is just an artist's illustration of what we want to find out about the surface of Venus. It also carries an infrared detector as well to seek out heat sources and heat signatures from its surface. So together, all these instruments will provide us with data on the planet's past and its present geological processes from the core to its surface. And the data gathered could be a model for Venus-like exoplanets as we find elsewhere in our universe. So very exciting development.
Yeah, it seems to me with all those volcanoes, Venus could be the most volcanic object in the solar system if enough of them are erupting. We'll have to see it compared to Io. But what if we go the other direction? We go out. Now, I know Olympus Mons, and there's those 3 volcanoes. Mars has the largest, but they've said Olympus Mons has been extinct a long time. So, Chris, is there any notice or any information? Maybe there's something going on out at Mars?
Well, yeah, hold on about the extinct business. Now, Mars famously has volcanoes. Famously, as you point out, most of our viewers will know Mars has volcanoes, and not just the big 4 that are in the center of the view here, but also a whole bunch of other ones stretching back through Martian history. We've never seen a volcanic eruption on Mars. We've never seen one, but then again, we haven't been looking for all that long. We haven't been looking constantly. It's possible we could have missed something, but more likely, it just doesn't erupt as often. The question is, could it still do it today? And we've actually got some new research on that. On the left of your screen here, you can see the famous big volcanoes. And you mentioned Olympus Mons. Now, Olympus Mons is a relatively recent volcano on Mars, going back hundreds of millions of years. When it last erupted, well, they have to make estimates on that. And the way they do that's by what's called crater counts. If a surface has been exposed out on the surface of Mars for a longer period of time, it will be hit by more meteors that will come in and smash a hole in the surface. The more hits, the older it is. Well, the estimates for the last lava flows out of Olympus Mons range the estimates from 100 million years, and that's not very long now. Not 100 million years is not that long compared to the history of a planet, but the short end of the estimates, 2 million years. So that wouldn't qualify as being a very long time ago to a planet. If it was that number, well, then maybe something would possibly still be able to happen. But we got some new research from the other side of the planet, not here with Olympus Mons. And over on this side of the planet, here's a map of a place called Elysium Planicia. And at Elysium, we have another volcano. You see it there on the top to your left. That's Elysium Mons. That's an older volcano, though. That one they don't expect to erupt. They don't think it's erupted in 1.5 billion years. But the thing that's interesting, there's a whole series of cracks, or what the geologists call fossae, in the surface surrounding this area. And these cracks, you see, I've marked Cerberus fossae. That area of cracks, they're very dramatic. We've seen them for years. There are pictures we've been taking from orbit of these, and they're pretty steep cracks. Now, they've been thought of as being tectonic. The whole area is raised a bit. It seems to have been stretched apart, and cracks like this will form in an area that's being raised and stretched. But just recently, Dr. David Hovarth of the Planetary Science Institute was taking a closer look at orbital images of one of these cracks, and this is what he found. Now, that's not just a crack. That dark marking you're seeing on the surface there is 8 miles across for scale. This is not tiny. Most of downtown LA would fit in the crater that's next to it for scale. What they did is they looked at this feature and they checked its chemical composition as best we can with the instruments we have in orbit, its distribution, how it's shaped and everything else. And what it looks like, and Dr. Reitzel mentioned this earlier, is something called a pyroclastic explosion. Not a lava flow of liquid lava, but instead a gas-powered explosion from inside the planet that hurls out rocks and ash onto the surface. This is like what happened at Pompeii. On Earth, these things are very dangerous. Of course, there's nobody down here. The big question we have is, how recent is this? They're doing the crater count tests on this and other tests, and it looks like it might be within 50,000 years of now. That's not 100 million. That's not 2 million. That's 50,000 years. And in geology speak, that's last Tuesday. So if this thing did erupt 50,000 years ago, we've got our answer. Mars is not asleep. Mars could do something at any time. And maybe it's Cerberus fossae. So keep your eye on Cerberus fossae. Now, there's more to the Martian geologic story. I mentioned there were older volcanoes, and I want to mention that Martian geology is really important with regard to past habitability of Mars, whether it was a warmer, wetter planet, as they think, because volcanoes produce gases that go into the atmosphere. They can help warm a planet. And we think that was true with Mars in the distant past. Now, the Martian geologic timescale, all those things I just showed you, Cerberus fossae, of course, but Olympus Mons, yes, all the volcanoes near it, even old Elysium Mons, all operate within the most recent time period of Martian history, geologically, which is the Amazonian period. The possible time when Mars might have had large amounts of water on its surface, a thicker atmosphere, a stronger magnetosphere, all these things you might need to support life, that's back in a period we call the Noachian. The Noachian period is about 4 billion years in the past. And you might think we couldn't get any clues about what Mars was doing volcanically back then, but that's not true. They were looking at a different part of the planet. This is an area known as Arabia Terra, and that's the greenish area in the top center and slightly left of your screen. There were lots of impact craters that scientists had been looking at for years and years and years in old photographs, but in 2013 they realized some of these craters may not be impact craters, like, for example, this one. Ismenia is, well, it's no longer even called a crater. They call it a caldera because they think This is the mouth of an extremely ancient volcano, back from that Noachian period when we think that there was more water and atmosphere on Mars. And not a regular sized volcano, a super volcano. It's been worn almost flat, but it does give clues that it's not a crater. For example, it's not completely round. And geologists recognized other structures that suggest that this is actually the muzzle end of a gigantic supervolcano. But how can you prove that? Well, just recently, Dr. Patrick Welley of the Goddard Space Flight Center started looking in detail at images not where the calderas are. You'll see those in the west to the left of on the diagram there. They're colored in red. They didn't look there because the evidence is a little harder to see. But volcanoes of that scale would lay down huge deposits of ash all the way across Mars, and computer models suggest the wind blew predominantly to the east or to the right, draping across all those lands that you see there to the center of your screen. Well, Dr. Welley's team was able to look at them carefully and identify that there, for example, here, there are huge ash deposits. Deep ash deposits, in fact, deeper than a kilometer. And they were also able to demonstrate by looking at the pictures that these had not been erupted somewhere else and carried in, say, to a crater by the wind or by water, but instead that these beds of ash are lying right where they were laid down. They're pristine. So this suggests that early Mars really was much more volcanically active, and they may have had a big role in giving it a thicker atmosphere and making it potentially a better home for life. So volcanoes are awfully important.
Yeah, they absolutely are, and that's fascinating about Mars, and to hear that there may be super volcanoes and eruptions nearby, and I'm still then I'm going to hold out for Olympus Mons as well. If only a couple million years, maybe. That's not that long ago, so who knows? Anyway, I've always been fascinated with volcanoes, and I find them really interesting, just geologically, creating new land, bringing it from the inside. There's a certain mystery to them and a mystique. Well, there have been a lot of eruptions recently, but this is just what Earth does. This really isn't anything that crazy. Here's Iceland erupting. If you're in Reykjavik, in the background, there were 200-meter tall lava fountains recently, just this year. Have been some really crazy scenes from Iceland. Just this week, as we were preparing this study, a couple nights ago, I heard about Kilauea erupting, which of course is on the big island of Hawaii here, and you can see, this is the tweet I saw. Well, that escalated quickly. It was just a little bit of heat coming out of the lake, and all of a sudden the entire lava lake on Kilauea, this is the main caldera, turned over and started erupting. And you can see here more of that lava breaking through that cooler crust on the surface. And then finally, in this little movie here, you'll see overnight, this is an infrared view. The entire surface pretty much just boom, turns into liquid lava. And then I saw this movie of a fountain down in the caldera down there erupting. These are a couple 100 meters tall. That's like a 5-story building you're looking there. Yeah, so this is, you're not a couple hundred on this one. This is like a 5-story building, whatever the height of that would be. That's like 50, 60 feet tall, probably. Now, there have been other eruptions going on as well, of course. Mount Etna has erupted over 50 times just this year. It seems to be continually erupting pretty much. It's just going on and on and on. But one that I found particularly interesting and one that resonates with astronomers is the one that's happening in La Palma right now. I put the pin there on the map where La Palma is, off the coast of Africa. Maybe plan your trip there. You can go to Casablanca and then, fly out straight over to La Palma maybe. These are the Canary Islands, by the way. And you can see here a picture of them, beautiful islands off the coast of Africa. And La Palma is that one, the one that's kind of almost all the way to the west. There's one slightly more west, but it's the northwest of the two. And the astronomers pick this one because the air coming off the ocean is very smooth. There are no other masses near there from the direction the wind comes that causes the air to tumble, and tumbling air distorts the images, and we want very clear images. So we put telescopes there on La Palma. And in fact, Here's a list of some of the telescopes there. You can see mostly European telescopes are up there, but the Galileo National Telescope is there, the Isaac Newton Telescope. A lot of famous telescopes are up on the Palma. Some pictures of them right here on the Canary Islands. Spain owns these islands, but the community there in the Canary Islands is very pro-telescope. They love them. They're relatively quiet. They don't make a lot of noise. There isn't a lot of pollution from them. You get to have research, and honestly, Spanish astronomers probably get some of the time on these telescopes because they happen to be there. So it's a win-win for the people of the Canary Islands. It's an industry that just keeps paying back for them, and they want more telescopes there, and it's a pretty darn good location. Probably the second best location to Hawaii, in my opinion. Chile, at least in terms of Northern Hemisphere. Chile is better for Southern Hemisphere. Now, why are we talking about this? Well, La Palma's volcano went on yellow alert due to all those earthquakes. These are earthquakes happening, and you can see the latitude and longitude of them picked up, and boom, right on the island there. And they thought, this isn't good. Yellow alert, that's probably going to erupt sometime soon. Now, this gentleman happened to be okay, well, not when it was erupting. This isn't even La Palma, but this is a Canary Island. And
yeah, this is Tenerife.
Okay, Tenerife. Now that's a volcano behind you. I assume it's not erupting.
But it has erupted in historic times. All the Canaries are volcanic.
Yeah, absolutely. So this is what it looks like. This isn't. People think of volcano, tropical island, or whatever. No, I mean, these are desolate. These are lava flows. There's not a lot of plants in a lot of these places. So dry and interesting. Now down near the coast, sure, plants, and it becomes very fertile ground and really, really good for growing things and farming. But up on the volcano itself, you have to wait for it to get weathered and break down those elements that are coming out of the volcano. Now from space, the eruption, it did happen. La Palma erupted. There wasn't just a prediction it was going to happen. It did, and this is what it looked like from space. You can see it literally, there's the cloud of the eruption, the ash cloud. Now these are known as gravity waves. As that plume works its way upwards, it's causing a disturbance. In fact, it's blowing these clouds back here. It's creating essentially its own weather around the island and pushing across the clouds. You can see here where they measured the sulfur dioxide coming off of the volcano from space. So you can see this is traveling a really long distance all the way over to Italy. Depending on the wind, it's going out in the ocean, wrapping around. Sulfur dioxide is not good stuff. You don't want to be breathing that. Here's the volcano itself, and as you can see, there are communities nearby. This is a night shot of it early on in the eruption, but very rapidly that eruption formed a lava flow and headed down towards those communities. And as you can see here in this photograph, indeed, the lava reached home. So this is not just a spectacle to take a look at. We need to remember lives are being affected here. Now, this wasn't a fast-moving flow, so the people had plenty of time to move, to get away, and to get out of the path of it, but lives are changed. People's homes, their memories, things they cared about and their living, but hopefully they were able to get themselves and their family away. So just beautiful photographs from Michael Reisch, who's, again, a friend of mine. It's about a kilometer away, caught this one, and you can see the civilization down below and the lava flow getting closer. And here's a close-up view. Just amazing stuff. And I noticed in the background here, these must be homes. Yeah. Because the lights are too evenly spaced. That isn't lava, folks. That's a community with the lava flow cutting right through it. You can see here the map of that flow, and it has indeed reached all the way to the ocean. So it's gone to the ocean and creating new land. You can see it down there. That's called a lava delta, actually, is being formed down there in the ocean. And that's the infrared view from space of that lava flow. Here it is reaching the ocean. This is just from, I think, yesterday. And there's a close-up of that lava delta. So the material's coming down, going into the ocean, making new land. Now, if enough lava goes out there, that land will stick around. This will be a new part of the island. If only a little goes in, it can erode and quickly disappear. But this flow's been very strong. I have a feeling new land has been created and there's new beachfront that's happening. Some more images, again, the human aspect of that. You can see the wall of lava approaching. Yeah, and you think, lava crashing into a swimming pool, everybody wants to see that, but then you remember that was someone's swimming pool. This wasn't just, crashing into a swimming pool, but all the same, glad they caught it. And here's a video. We're just going to play it for a while and listen to just how crazy this all is.
Y esto es lo que... Ya, qué guapo, la colada magmática. Está avanzando prácticamente a metro por segundo. Bueno, metro por segundo a lo mejor no tanto, pero medio metro. Hostia, cuidado. Cuidado con el encendido, vale. Vamos retirándonos ya.
Yeah, now I don't speak Spanish, so I'm going to trust that gentleman wasn't swearing, but I don't know, seeing that coming through my town.
Well, yeah, it's like the running of the bulls, except it's lava. That's incredible.
It's
That
lava
looks
and there's
terrifying.
terrifying, no way to avoid it, and it's just coming at you. So, you take a look at this, and this is what they've been dealing with on La Palma. So although it's a fascinating eruption, the telescopes are fine. They're off on a different part of the island, but the ash plume could reach them. It's reached heights about the same height as the telescopes that are up around 4,000, 5,000 feet. So this is, this is some astounding footage that we're getting of this eruption. That's going to end our section tonight on the La Palma eruption and on volcanoes in the solar system. They are fascinating objects and fascinating things that are happening. And this is just how things work. When you put together an object like the Earth or another planet, the interior stays hot. And as the exterior shrinks and cools, it cracks, and that heat wants to get out. So it finds a way. And I hope you find a way to join us again next month on the first Friday for All Space Considered. We'll be coming back, and we've got a show, a very special one planned for you. We have some guests from the NOVA program about their new show about the universe. So we're going to preview some of that. We're going to talk to the people that made it. We had it not exactly planned out quite yet, but we're lining that up for you. Should be a really good show. We're excited about it. And once again, I want to thank Patrick and Chris for joining me tonight. I want to thank Bill, our whole team that puts together this wonderful program. And I want to thank Griffith Observatory Foundation for all they do to support everything we do. I want to thank everybody that donated tonight and that's joined the foundation. And remember, Griffith Observatory presents and produces All Space Considered and all the other programming that you're seeing here. It is run by the City of Los Angeles and the Department of Recreation and Parks. And like I said, we do it in partnership with Griffith Observatory Foundation. So thank you all for joining us tonight, and we'll see you next month.
Good night.